The difference between a sequence and a series is that a sequence is just a list of numbers, whereas a series is the sum of all of the numbers. So in this case, we have the series 1 plus 3 plus 5 all the way up to 121. So we can see that this is an arithmetic series, and the common difference each time we're adding 2. So the common difference is 2. Part A asks us to find the sum of the series. Well, in order to find the sum of the series, we need to use the formula for an arithmetic series, which we need to have memorized. The sum of however many terms is the number of terms times the first term plus the last term, all divided by 2. Well, in this case, we know the first term is 1. We know the last term is 121, but we don't know the n value. We don't know how many terms there are because we don't know how many they skipped. So we need to find out what number term this is. So the n value is what for 121? In order to find out the n value, we need an explicit formula. So the explicit formula for an arithmetic sequence would be a sub n equals a sub 1 plus n minus 1 times the common difference. Well, here our explicit formula is going to be a sub n equals, the first term is 1 plus n minus 1 times the common difference, which we found out was 2. We want to know what term, what n value 121 is. A sub n stands for the term, n just stands for the number. So we know the term, so we're going to plug in 121 for a sub n, and we're going to solve for n. So you have two options. You can simplify the right-hand side and then solve, or I can just subtract the 1, divide by 2, and then add the 1 to the other side. We get that there's 61 terms. So then we just plug into the formula. S sub 61 equals 61 times the first term plus the last term, all divided by 2. When you type this into the calculator, you get that the sum of the first 61 terms is 3,721. So that would be our final answer. Now another option of doing this once I find the recursive formula is I can just write it as a summation. So that would be the summation from when x equals 1 all the way up to when x equals 61, and then the arithmetic sequence in explicit form goes next to it. You would type this in the calculator and you'd still get 3,721. Part B asks us to find the 12th term. Now we already wrote the explicit formula, so all we need to do is use that to find the 12th term. Well, the 12th term means when n equals 12. So that means a sub 12 equals 1 plus 12 minus 1 times 2. So this gives us 11 times 2, which is 22, plus 1, which gives me 23. So this means that my 12th term is 23. Now part C asks us which term is 91. Again, we have our arithmetic explicit formula. If the term is 91, that means instead of a sub n, we plug in 91, and then we solve in reverse for n. So again, you can simplify the right-hand side first if you want, or you can just subtract the 1, divide by 2, and then add 1 to the other side. I get that n is 46, so that means that it's the 46th term. Given the series 2 plus -4 plus 8 all the way up to 32,768, we're asked to find the sum of the series. First, we need to identify that this is a geometric series, and the common ratio is -2. Now, to find the sum of the series for geometric, the formula given to you on the reference sheet is a sub 1 times 1 minus r to the n power divided by 1 minus r. Well, we know that the common ratio is -2. We know the first term is +2, but we don't know how many terms there are. We need to find out what number term this is, and to do that, we're going to write an explicit formula for this geometric sequence. So a sub n equals, the first term is 2, the common ratio is -2, all to the n minus 1 power. We're looking to see what n is when a sub n is 32,768. We cannot multiply the 2 and the -2 because -2 has an exponent, so I'm going to get the number with the exponent by itself. This gives me 16,384 equals -2 to the n minus 1. I cannot divide by a -1 because the -2 is being raised to the power. So I need to rewrite 16,384 as a power of -2. Well, I know that it's going to have to be an even exponent because I'm getting a positive number. After trial and error, I can figure out that -2 to the 14th power is 16,384. Now, since the bases are equal, I can set the exponents equal. Solve for n, I get that n equals 15, so this is the 15th term. Now, another option usually is to take the log of both sides or to rewrite it as a log, but because we're working with negative numbers and because it's always possible with series, we want to get the bases to be equal. So now I can plug the information I know into my geometric series formula. The sum of, we just found out the first 15 terms. The first term is 2, 1 minus, the common ratio is -2, all to the 15th power. The -2 to the 15th power, all over 1 minus -2. We can type this into our calculator, and we'll get that the sum is 21,846. Now, another way to do this is to write it using summation notation from the first term up to the 15th, and then the explicit formula goes next to it, using the same variable that you used down here. By pressing math, going down to number 0, hit the summation button, type in all of your information, and you'll still get 21,846 as your answer. You may solve it either way, either using the formula or summation notation, unless the question specifies, but if it just asks for the sum of the series, either one is acceptable. Part B asks us to find the 12th term. We already found the explicit formula for the geometric sequence. So to find the 12th term, we just let n equal 12. We're going to do -2 to the 11th power times +2, and we get that the 12th term is -4,096. For part C, it's asking us which term is 8192. So we plug that in for a sub n, again into our explicit formula, and we solve for n to find out what number term it is. We need to get the base that has an exponent by itself, so we do 81,092 divided by 2, and we get 4,096. Then we want to figure out how to rewrite this using -2 as the base. We know that it has to be raised to an even power because it's a positive number, and after trial and error, -2 to the 12th power gives me a positive 4,096. We set the exponents equal, and we get that n equals 13, so it's the 13th term in the sequence. Finally, part D asks us the sum of how many terms would be -682. So I'm going to plug in the -682 for S sub n. I know that the first term is still 2. 1 minus, the common ratio is still -2, but now I don't know how many terms I added. So it's assuming that this isn't the last term in the series. All over 1 minus -2. So I need to simplify, so I'm going to divide both sides by 2, and that's going to give me -341 equals 1 minus -2 to the n, all over 1 minus -2, which is 3. I'm going to multiply both sides by 3, and that's going to give me a negative 1023. Then I'm going to subtract the 1 to the other side, so that's going to give me a negative 1024 equals negative 2 to the n power. Now I can't get rid of the negative 2 inside the parentheses, but I can divide by negative 1 in both sides and get now that positive 1024 equals negative 2 to the n. I want to rewrite 1024 as negative 2 to a power, which I know must be an even power. And negative 2 to the 10th gives me a positive 1024. Then I just set the exponents equal, so I get that n equals 10. This means that the sum of the first 10 terms equals negative 682. Given the series negative 1 plus negative 3 plus negative 5 going on, this question is asking us to find the sum of the first 12 terms of the series. Well, we can tell that this is an arithmetic series because each time we are adding negative 2. There's a common difference of negative 2. The sum of an arithmetic series is n times a sub 1 plus a sub n all over 2. So the sum of the first 12 terms of the series is going to be 12 times the first term plus the last term. It's the last term that we don't know. In order to find the last term, we need to write an explicit formula. So the first term plus n minus 1 times the common difference, which is negative 2. Well, we want to find the 12th term because that's the last term. So we plug in 12 for n. And that's going to give us that the 12th term, once you type the right-hand side into your calculator, 11 times negative 2 is negative 22. Negative 22 minus 1, or plus a negative 1, gives me a negative 23. So this is the last term that I plug in for a sub n. This is going to give me negative 24 over 2, which is negative 12, times 12, which gives me negative 144 as my sum. If you wrote this in summation notation, the n values are going from 1 up to 12. The explicit form would go next to the sigma. And if you type this into your calculator, even if you were to simplify this, you should still get negative 144 as your sum. Again, you can solve either way using either the formula for arithmetic series or by writing it in summation notation. Given the series 48 plus 24 plus 12, find the first 7 terms of the series. Well, we can tell that this is a geometric series because it has a common ratio of 1/2. Each time we're multiplying by 1/2. Well, when we're finding the sum of a geometric series, we use the formula a sub 1 times 1 minus r to the n all over 1 minus r. We know that we're finding the sum of the first 7 terms. We know that the first term is 48, and the common ratio is 1/2. Please put it in parentheses because it's all being raised to the 7th power, all over 1 minus 1/2. Now, geometric series are nice in the sense that we don't actually have to find the last term. So we type all of this into our calculator, and you should get 95.25, which you can also write as 95 and 1/4 or as an improper fraction. Just don't round it because it is a finite decimal. Now again, it would have been possible to write this in summation notation from the first term to the 7th term. We just would have had to write this using an explicit formula, which is a little bit more work here. So a sub n would equal the first term times the common ratio to the n minus 1 power. That's what goes next to the sigma. We're going to use an x instead of an n, since we used x down here. You type all of that into your calculator, and again, your calculator will give you the same answer, 95.25, and that would be the final answer.